In episode 3, we tracked exactly how much each token costs, and we ended with a question. What's the fastest way to start cutting that bill right now before touching your architecture, before adding any new tools? The answer is fix your prompts. Today, we're starting layer 1 of our optimization framework, output control. Specifically, how a single line added to your prompt can cut your output token count in half. No code library, no infrastructure change, just words.
Last episode, we left you with this cost formula. Input tokens plus output tokens plus cached input times price per token equals your bill. And I told you, output tokens are more expensive than input tokens on most providers, and you're the one controlling how many the model produces. So today, we attack that number directly.
Bad prompt. Let me show you what I mean. Watch what happens with a bad prompt. When user query send prompt, tell me about caching, check model feedback on moving GIF image on the right side. Look at that. It gives me a definition, a history of caching, types of caching, hardware versus software caching, use cases, examples, maybe a closing summary, easily 400 to 600 output tokens. And maybe I only needed 2 sentences. I asked a vague question. The model filled the silence. So rule says vague prompt means model decides the length, means unpredictable cost.
How to fix? The fix is simple. Tell the model exactly how to respond. We call these output control instructions, and they go inside your system prompt or at the start of your user message. In other way, update model instruction or system_prompt to include one of 4 ways from instruction type, as in table shown. 1. Length constraint. Reply in 1 sentence. 2. Format constraint. Return only JSON. 3. Role constraint. Act as a teacher or any job. 4. Scope constraint. Answer only what Python is. Do not discuss uses. Briefly, simple memory trick. Length arrow, how much? Format arrow, in what shape? Role arrow, who are you? Scope arrow, how far should you go?
Now it is time for code part. In next scene, we'll show Python code example for poor prompt and how you can fix it by apply 4 types of instruction type. Let us start.
Hello. This is a cool part. In this lab, we will talk about bad prompt and how to fix it. Let's start. First, we install needed library, python-env, that needed to load API_key from .env file, and Anthropic, that is needed for use for Cloud API call. Let's run. OK. Secondly, we loading Cloud API from .env file here. Let's see. First, import OS. Then import load.env. Then go to catch the define Anthropic_Cloud_API from .env file and store it in this variable. Then check if Anthropic_API_key is loading correctly or not loaded correctly. If not loaded correctly, then print Anthropic_Cloud_API not found in .env file. If Anthropic API is loaded correctly, then print normally Cloud API key loaded successfully. Then print the last 10 character for the Anthropic API key. Let's run. Now, Cloud API key loaded successfully and last 10 characters from the API. OK. Then start using API, Anthropic API call.
This part or this structure, before it, you can go to this document, okay?
of the Claude. Just double click to see how the structure of the Claude from this. Okay. Now I go to the Claude API document. In make your first API call, go this and you can see here, okay, this is a part of the code structure that make importing for the Anthropic. We just follow this exactly in our Python code part. Go back to our code here. Firstly, we make imports Anthropic, then make Anthropic and pass the loaded API into this object. Then from this object, I make object.message to define the model used and the maximum token and the messages. Here the message I give, a message here means the user query. The user query asking about this is question of the user, and then this is the rule defined as a user. You notify here in this structure, we didn't mention any system instruction. So in this case, if you didn't define any system prompt, that means the model is running on its training default. And that means the model didn't have any limitation, and he can answer with feedback according to his training data. Okay. Then I here make for the bad response here the result. Okay. I go to .usage.output token to extract the number of output tokens here, the count, and store it in this variable. Then print the number of tokens and then print the feedback, context feedback of the Claude API. Okay, let's run this. Okay, you see the output. The output here is output token. Number of output token is 901, okay? So you can see the structures if we open this text to see the full. Here you can see the he answering, okay? The caching, a comprehensive overview. What is the caching? And this is the caching definitions. Then I make a core concept, then give him a key benefits and this type of caching, okay? And by strategy and the caching strategies and is a model, give him all, okay, full details, feedbacks about the user query in this case that didn't define with any system instructions. This give a number of tokens is 901 output tokens. Okay. Let's go to the next and very important part of this lab is how to fix this issue. This we can call it a bad prompt. Why bad prompt? Because here the model is left to feedback from its training data without any limitation, without any instruction given to him. And this give us 901 output tokens. For here, I will try to fix. What the added value, what's the update and the tuning for this code is just I use same structure by the same model and the maximum token, but only I added this instruction as a system instruction in this part. In this part, system instruction, I defined 4 types of instruction types. We already mentioned before in this episode, and the way they start to run one by one and monitoring the number of output tokens to see the difference, okay? Here, you see the same query the user sent. Tell me about the caching. So, and I will start with first one that belong to length constraints, okay? What this? I just mentioned system reply in 2 sentences or fewer. Okay, let's run to see the output. See, now the output token is 62 only, and this is the answer of the model. Caching stores frequently accessed data in fast, easily retrievable locations like RAM or browser to reduce the load timing and computation overload. Okay, you see? Now I got useful answer from the model with very low output tokens, 62. Before this, if you remember, on the go upward, we took about 901 output tokens. Here, for applying fast instruction type that belong to length constraint, I result 462 output token. Okay, let's try second type of instruction. That is for mass constraint and runs the code and monitoring the output tokens. Okay? You see? The output token is increased and became 377, but is still more or less than 901, the output token with bad prompt. Okay? But more. You can see also the answering is also give a good answer, but more details than first instruction type. Okay? Let's try next one that belong to role constraint. Okay? Act as a direct answer engine. Okay? Let's see the output. See, now the output token 390 is the highest output token that belong to this instruction till now, and the lower will be the first one. Okay? You can see also give useful information with more details about it. First, let's try last one of instruction type, that is scope constraint. Okay? That give him a system answer only what is asked. Don't elaborate. Let's run this code. Okay, now I run this code. The number of token is 220, 210, and 210. So here I tried all 4 instruction types. Okay. We can see the lowest one is, first one is length constraint. Okay. And the second one in number of tokens is the last one, scope constraints. So from this we can conclude, you have to put system instruction to your model to lower the output tokens and decrease the cost for these tokens. Now, if I want to go more, okay, and go to the comparison and to calculate the saving money for these actions. Okay, we are talking about before applying any system, we are talking about 901 output tokens, and 4 after applying system instructions. And in this case, we apply, for example, I left this type about scope constraints. We got 210 tokens. So we are applying. Let's calculate the cost, okay, and the money saving from this token fixing action. So here, firstly, we are using Claude High-K for -5 models. This model have output price per token is $5, okay, per 1 million token. So here, price per token, $5 divided by 1 million. Then for this give you price per token. Then I multiply price per token per the bad output tokens, number of tokens in the first one, which 901. Then price per token multiplied with the good output token that is already optimized is 220.10. So it's the bad cost and the good cost. This is a cost in dollar signs, okay? Then I make a print. Also, I make a scale for this for assumption. So if I make 1 million call per month, okay, what will be the cost? So for bad cost, I multiply by 1 million, and also for good cost. And then the saving is monthly bad minus monthly good. And the ratio saved is equal the saving, the difference between the bad and the good, prompt divided by monthly bad prompt. Okay? To see the ratio of the saving we achieved. Okay? Then this print all the result. Let's run this code, and this is output. Here you can see, for bad prompt, we give us this price of dollar, and for good prompt, we give us this. You see,
The bad prompt is higher in cost than the good prompt. And if we expand it to be 1 million core per month, the bad prompt, we pay for it for 4,505. And for good prompt, you pay for $1,050. So you save a money around $3,455 you make a save per month. This ratio represents around 76% of the bad prompt you save. So you save around 76% from the money when you're just fixing the bad prompt to be a good prompt. So our conclusion here. The new prompt means model will decide the token output lengths with unpredictable costs. But by defined will output system structures from 4 types of instructions we mentioned before. You can set under control the output token lengths, not the model, hence decreasing the output token price. Here's the mental model I want you to take away. An LLM with no output instructions is like an employee with no job description. They'll do something, probably too much, probably not exactly what you needed. Output control instructions are the job description. Short, clear, specific. You get exactly what you ask for, and you pay for exactly that. No output instruction means the model decides your cost. But prompt instructions are soft control. You're asking the model nicely. What if the model ignores you? What if a jailbreak or an edge case causes it to run long? Next episode, we add a hard cap. We cover max_tokens, the guardrail that enforces a ceiling on output length no matter what. Layer 1, Method 2. See you there.